Okay, so today we're learning about inverse functions. This is 10-7. So we're going to do some guided notes. The inverse of a function reverses the order of the outputs, which is your y values, and the inputs, which is your x values of a function. So basically whatever your x values are now become your y values, and whatever your y values are now become your x values. The inverse of a function is usually read f to the negative 1, which is read f inverse. So you read this as f inverse. A function f has an inverse function if and only if the original function f is 1-to-1. For a function to be 1-to-1, that means both the x and the y values cannot repeat. So it has to pass both the vertical line test and the horizontal line test. Okay, so for this first example, it says to find the inverse of the relation. So all you have to do for this is remember, your x values become your y values, and your y values become your x values. So all you have to do is you just have to flip all of the coordinate points. So the coordinate point 2, 4 now becomes 4, 2. This coordinate point 6, -1 now becomes -1, 6. This one 8, 3 becomes 3, 8. This one 5, -7 becomes -7, 5. Okay, that's the inverse. All right, so now this one, this is a table of values. We do it the same way. So if I want to find the inverse function, I'm going to make my table of values, x, y. So -1, 2 now becomes 2, -1, 4, 3, -5, 0, 11, 6, and 8, 5. Those are all of your values. Okay, next, slope. How is the slope of f inverse related to the slope of f? So what we're going to do first is I'm actually going to take all of these values in the table and I'm going to flip them around. So this is the table of f. So if I want to make a table of f inverse, I'm going to flip all of my x and y values. So we now have 6, 0, 8, 1, 10, 2, and 12, 3. I'm going to find the slope for f, and then I'm going to find the slope of the inverse function. So you could pick any 2 points you want in this table to find the slope. I'm just going to pick the first 2 points for both of these to keep it simple. So if I'm doing the slope of f, okay, remember slope formula is m equals y2 minus y1 over x2 minus x1. My points are 0, 6, and 1, 8. That's what I'm choosing. So 8 minus 6 over 1 minus 0. That's 2 over 1, which is just 2. Then if you want to do the slope of f inverse, I'm going to pick these 2 points, 6, 0, and 8, 1. I'm going to plug into slope formula. So let's do 1 minus 0 over 8 minus 6, which is 1 over 2. So how are these slopes related? They are multiplicative inverses. They are multiplicative inverses. So basically that means if I did 2 times a half, I'm going to get 1. When you multiply the two numbers, you get 1 if they're multiplicative inverses. Okay, example 3. Next, find an equation for the inverse for each of the following relations. So when you do this, you have to first switch the x and the y, and then you solve for y. So the first thing you do is where y is, you put an x, and where x is, you put a y. So you're substituting x for y, and you're substituting y for x, okay? So you're just switching the x and the y. Now, that's step 1. Step 2 is you need to solve for y. So you need to isolate the variable y. You need to get y by itself. So in order to do that, I'm going to subtract 6 on both sides. So x minus 6 equals 2y. Now to get y by itself, I'm going to divide by 2. Now, some people might leave it like this, x minus 6 over 2. I would not do that. What I would do is I would write it as, remember, write your inverse notation, y inverse. Don't just write y. Y inverse equals x over 2, or that would really be 1/2 x, right, minus 3, because negative 6 over 2 is negative 3. That's really how you should write it. That's fully simplified. Okay, next one. So first step is we need to flip x and y. So we need to substitute in x equals y squared plus 6. Now, you can kind of ignore this. The reason why it says x is greater than or equal to 0, if we think about this, this is a parabola that's moved up 6 units, okay? That's what this looks like. However, parabolas are functions, but they're not one-to-one because they pass the vertical line test, but they don't pass the horizontal line test. So it's saying you only want where x is greater than or equal to 0. So what that means, just to show you visually here, is basically it's a parabola that's moved 1, 2, 3, 4, 5, 6, up 6 units, okay? So it looks like that. But you only want where x is greater than or equal to 0. So you only want this portion of it, okay? And now that makes it a function because now it passes the vertical and the horizontal line test. Now it's one-to-one. Before it wasn't because it would cross through 2 points there, okay? So that's what that means if you're curious. Okay, now we plugged in x into y, we plugged in y into x. Now we need to solve for y. So I'm going to subtract 6 on both sides. So now I have x minus 6 equals y squared. To get y by itself, I'm going to take the square root of both sides. So y equals the square root of x minus 6, y inverse. The inverse function, square root of x minus 6. Okay, next one. This really says y equals x plus 7, right? Because we know f of x means y. So we are going to move this up real quick just in case you can't see. Okay, so we're going to substitute x here, and we're going to substitute y there. Now you're going to solve for y. So it's simply just y inverse equals x minus 7. Simple. This one, x equals y squared. First step, substitute your values. Solving for y, square root. Y inverse equals square root of x. Okay, last example, we're going to be graphing inverse functions. So I'm actually going to use a pen for this. I'm going to use 2 different colors. The first thing I'm going to do is I'm going to find the inverse of this function. So y equals 3x minus 2. So what I'm going to do over here is I'm going to substitute x in for your y and substitute y in for x. So now you have x equals 3y minus 2. Now solving for y, add 2, x plus 2 equals 3y. Divide by 3. So now we have y inverse equals x over 3. Remember, that's 1/3 x. You could put the 1/3 there if that helps you. Plus 2/3. Okay? So we are graphing. I'm going to graph this function right here in blue. I'm going to graph this function in blue, and then I'm going to graph this function in red. Okay. So starting off with 3x minus 2, that's a line. Our y-intercept is -2, so we're going to go down 2 units. Then we're going to go up 3 over 1, because that's our slope. 1, 2, 3 over 1. 1, 2, 3 over 1. Opposite direction. Connect the dots, make your line. Okay, now for this one, we're gonna go up 2/3. That's a little weird. So not up 1, up 2/3 is maybe right about there. And then I'm gonna go up 1 over 3. So up 1 would be to about here, and then over 1, 2, 3. So that's here. I can do the same thing in the opposite direction. Okay, and then you just connect the dots. All right. Now, the other thing you can do is you can actually graph this function, y equals 3x minus 2. And then what you could do is you could say, okay, well, I can see that this is the point 1, 1. So in my inverse function, if I flip those coordinate points, well, that's still 1, 1. So that's a bad example. And that makes sense because for my red function here, that's a point as well. If I took this point, 2, 3, right? And then, so this is the coordinate point 2, 3. If I flipped that, then the point 3, 2 has to show up on my red line. So if I go over 3 up 2, oh, that's a point. So another way you could do it, instead of doing it this way, is you could just flip all of your points on your line. And then that'll give you, and connect the dots, and that'll make a line of your inverse function. Now, inverse functions are always a reflection over the line y equals x. So the line y equals x is this line, right? Up 1 over 1, up 1 over 1, up 1 over 1. So I'm going to make a dashed line to show you what y equals x looks like. Okay, so basically it's reflected, your inverse function is a reflection over that line y equals x. So it's not like it's a reflection over the x-axis or the y-axis, it's a reflection over this line. So you can kind of visually see that, I think. Okay, next one. Graph y equals 3/4 x minus 1 and its inverse. So I'm going to go over here and I'm going to plug in x for y and plug in y for x. Now I'm going to solve for y, so I'm going to add 1, x plus 1 equals 3/4 y. When I have a fraction next to a variable, multiply by the reciprocal to get rid of it. Now when you multiply by 4/3 over here, you got to be careful because you got to multiply it through the entire equation, so put it in parentheses. So now on this side you have y inverse equals, this distributes 4/3 x plus 4/3. Okay, once again I'm going to graph this function in blue, and then I'm going to graph this function in red. Okay, so starting with this first function here, down -1, and then we're going to go up 1, 2, 3, right 1, 2, 3, 4, go the opposite way, down 1, 2, 3, 1, 2, 3, 4, connect the dots. Okay, and then for this one, I'm going to graph this in red. We are going to go up 4/3. So 4/3 is 1 1/3, right? Like if I converted that to a mixed fraction, that would be 1 1/3. So 1 1/3 is right about there. So that's my y-intercept. Now I'm going to go up 4 over 3 from there. So up 1, 2, 3, 4 over 1, 2, 3. So that's right about here. It goes off your graph a little bit, but that's okay. And then you're going to go down 1, 2, 3, 4 over 1, 2, 3, going in the opposite direction. It's about right here. And then you want to draw a line through your points. Okay, and that is your inverse function. All right, that is it. Have a good day.